Hello everyone, I'm Gunjan Aggarwal and I'm going to talk about our work Neuro-Symbolic Generative Art, a preliminary study co-authored with Devi Parikh. Generative art refers to an art generated using code and typically includes an element of chance. This element is linked to the use of an autonomous system which is generally non-human. The field has been there since quite some time, and here are some generative art forms created by distinct artists ever since 1900s. There are two classes of generative art approaches, symbolic and neural, and I'm going to slightly talk about both of these. Symbolic art is an art that is generated by an artist algorithmically and has some explicit parameters to control the generation. The artist designs these parameters, and an autonomous system generates samples within these constraints. Presented here are some symbolic arts generated by artists. Neural art, on the other hand, refers to an art that is generated by a deep neural network. Given samples from a data set, the deep neural network learns to generate new images from the input data distribution. Some artists tend to perturb the weights of these networks to add another layer of artistic touch to the generated art. Having explored the two art forms, symbolic and neural, we propose a new hybrid genre, neuro-symbolic generative art, which is an amalgamation of symbolic art and neural generation methods. Specifically, we use a symbolic art generator to generate a bunch of images by varying different parameters of control. Here, we are using Devi Parikh's tool available at stateoftheart.ai. Over the dataset generated by the symbolic approach, we train a deep neural network that can learn to generate additional samples. We believe that the organic, unpredictable aesthetic from neural approach would complement the crisp, designed aesthetic of symbolic approach. Let's now dive deeper into each of the components. We use the circle packing as our symbolic generator. Non-overlapping circles are placed at random locations in an image. We have two parameters of control here. First, the color palette, for which we have 5 options, and second, the number of colors within a range of 5. There's also a random seed that generates a new variation with the chosen parameter by clicking on Generate button. We generate some 10,000 different samples as a training dataset using this method. The beauty of this symbolic generator is that we can get as much data as we want with a large variety, as we can see here. Now let's jump to the neural network model, for which we use a progressive GAN. The progressive GAN differs from the conventional GAN in the sense that the generator and discriminator here are grown progressively. So we start with generation of 4x4 image, which is then doubled after 37k iterations by adding additional layers on top of the previous generator and discriminator. Our final generated image is of resolution 512. We call the final samples generated via the generator as neuro-symbolic generations. While the neuro-symbolic generations are generated by feeding random noise vector as input, thereby providing no user control, we can introduce some amount of control by performing interpolations in the latent space. So let Z1 and Z2 denote two random noise vectors and let alpha be the parameter of control. We generate a linear interpolation between Z1 and Z2. The interpolated vector is fed to the generator, which generates the corresponding image. Such interpolated images are referred to as neurosymbolic interpolations. Here, we can visualize different neurosymbolic generation samples generated via our model. And here, we can find 5 different neurosymbolic interpolations between two neurosymbolic generations. The corresponding GIFs on the right are at a step size of 25. We now jump to the evaluation criteria. We aim to evaluate both the final generated images as well as the generation process where a user can control the interpolations. We perform our evaluation via several human subjects using Amazon Mechanical Turk platform. Our main evaluation criteria is creativity, which is a phenomena whereby something new and somehow valuable is formed. Thus, creativity encompasses both novelty and value, and we aim to evaluate along these axes. Let's go into our first evaluation scenario, which is artifact evaluation. We aim to compare between the neurosymbolic generations, interpolations, and symbolic artifacts on different axes. We show users pairs of images and then ask them to contrast between the two via different questions. Now, if the image pairs are randomly paired, more than just the style of the art would likely differ. So, to control this, the pairs were formed by finding nearest neighbors across approaches using color histograms. This helps to minimize unrelated variations and helps focus the study on different styles of samples. We construct 60 pairs equally distributed across the three pairs of approaches. 20 human subjects participated in the study, resulting in a total of 1200 pairwise assessments. Example image pairs shown to the subjects are shown here. We ask users the following questions when comparing between two images. Which art seems more different from art you have seen in your life, looks better, is more creative, is more artistic, and seems more likely to be handmade? To sanity check that the users are answering properly and not randomly guessing, we also add another question which is to count the number of colors in the image. Since we know the number of colors in the symbolic image, we can use this as criteria to filter out users who are randomly guessing. The plot here shows the results of the human evaluation for the three approaches across each of the question type. Given the sample size, the dashed line indicates the ratio above or below which a ratio can be considered statistically significant. We find that the human evaluators rate neurosymbolic art as being more different, creative, and artistic than symbolic art. Subjects rate the three art forms almost equally in terms of quality. For the final dimension of naturalness or handmade, we see that the subjects find neurosymbolic art to be more natural or organic. Following our novelty plus value criteria, we hypothesize that this results in neurosymbolic being rated higher in creativity overall. For our second evaluation scenario, we ask users to compare between the live interactive generative tools for symbolic and neurosymbolic. Here we can see the two art tools. So the symbolic tool allows the user to choose a number of colors and also the color palette, and they also have an option to add an art to their favorites. They can choose up to 5 art forms and they can also delete some of them if they like and also copy the URL to clipboard to share with us. Using the Neuro-Symbolic tool, a user can change the interpolation ratio to generate a neuro-symbolic interpolation, as we can see here, which is controlled by this slider. The user can also vary the random seed to generate two neuro-symbolic generation images like this, and then this also has an option to choose the hybrid art and add it to their favorites. This study was done across 50 users and we asked which process generates better looking art, generates more surprising, unusual, or unpredictable art, generates more creative art, and is more satisfying to work with. The graph here depicts the proportion of times subjects preferred the neuro-symbolic tool over symbolic tool. Trends are similar to artifact evaluation. For the axis of better art or value, users like art generated by both tools equally. Subjects rate neurosymbolic art to be more unusual and creative than symbolic. Interestingly, while less creative, subjects find symbolic art to be more satisfying to work with. Thus, using symbolic tool is perhaps more analogous to Zen-like or relaxing activities, while neurosymbolic may be close to cognitively taxing creative activities. As a part of creation process evaluation, we also ask the users to share their favorite piece of art that they created and also write a few lines about it. We can see that our tool instills creative emotions in people. You can pause the video to read the comments if you would like to. Here's the link that you can use to play with our neurosymbolic tool. As future work, we plan to explore other symbolic art styles and also train a model over multiple styles to potentially discover entirely novel styles. We further plan to interpolate between two symbolic images instead of two neurosymbolic images. For this, we will explore techniques that map real images to latent representations. A user can then first design the two endpoints symbolically and then generate an intermediate piece neurally. Neither symbolic nor neurosymbolic approaches alone allow for this level of control. Thank you.